Hello guys, today we're going to talk about generics. This is a vital and fundamental feature which was introduced with Java 5 version. This is the first lesson in this module, and I think we should start from very beginning. In order to better understand generics, we need to understand the need of them. So I propose start from exactly this point. Why two generics were introduced into Java, how they help in Java, and so on. So I think it's time to move on from words to practice. I'm going to use IntelliJ for this module, and in this lesson I propose to write two different codes. One without usage of generics and another code with generics. So let's get started. I already have created a package com.generics.lessons. In this package, we will create a new Java class. So let's call it non-generics code. Inside this class, let's create a main method. And let's create a variable of type of list. We need to import it from utility package. So what we have here, we have object type of list. We named it countries, and we have instantiated it with array list. So the code which is written on this line number 8 is non-generic code, and the list is non-generic. We do not have any restrictions, you can see, and can add any type of object into this list. For example, string, integers, or even all objects which we're going to create in our classes, car as example, and so on. So the list without generics is also known as raw type of list. So you can see that as well from IntelliJ prompt, raw use parameterized class list. However, the code itself is fine and it will be compiled by compiler. Of course, the usage of raw type is not forbidden in Java, and we will come back to this question later on, but it's strongly not recommended. Okay, so let's go to the next line and let's add some countries to this list. So what we have done here, we have added two objects, type of string, into countries list. I don't know how you noticed or not, but when I'm adding any object, the argument which is expected exactly type of object. So let's stop here and jump into the slides. If we will continue to write the code without generics, with generalized code, we will face the following issues. So the first one is explicit casting. It means whenever we try to process string values which we added to our list, we will need to use casting of object into required type, which is string in our case. And we will face with another issue which is known as type safety or lack of type safety, because we can add any type of object into our list. So let's get back to idea and write the method which would print out countries into our console. Okay, so let's create a method. As I mentioned previously, let's call our method print countries, which is going to print countries which we pass as argument. On number 12, we write this method. We call this method countries, pass argument countries. Okay, we can see that integrated development environment cannot resolve this method because simply it's not yet written in our class. So let's write this method in non-generics code class on line number 14. So I propose to have this mm, private So what we have here? Access modification is private. I just want to have internal method which might be called only from this class. So static, since we simply print the countries and no object for that, according to my logic, should be required. Return type void. So basically we don't need to return anything. We just simply want to show the data in our cancel. We just simply want to print the countries. And this method accepts type of parameter list, which we expect to receive, and we call actually it list of countries. Simple. We choose this type list because on line number 12 we pass argument countries, which is variable type of list. So what do we do next? Let's try to get the value from that list. On line number 15, let's write following code. What do we see here? We have a string type of our variable to which we try to assign the value from the list under index number 0. So we want to print this country, Lithuania. Oh, I actually noticed mistake, sorry. United States. We would like to print the first value in our list, which is under index number 0. And it's supposed to be Lithuania. However, we see that compiler gives us a warning, and this project wouldn't be allowed to be compiled, so we couldn't run the program. The warning is, we can see required type string from the left side, and from the right side we have object. But you will ask why. We have provided string in line number 9. Yes, it's a string. And yes, you're absolutely right. We provided a string type of object. We even can do and write following code if you want. So basically we can write countries and again, we have created a new string and instantly added this new string into our list of countries. So let's try to retrieve the data. It's a 0. Lithuania under 0 index, United States under index 1, and United Kingdom under index 2. So if we try to do that, still we have the issue. So what we supposed to do? In this case, in line number 11, we explicitly created new string and added it to our list of countries, but still we receive compiler error. Compiler is not satisfied. But we know that list of countries contains only strings, so where is the problem? Why it doesn't allow to compile the code? The problem is actually that flower of all classes is object type, and since we have not explicitly declared what kind of list it is going to be, all arguments which are passed to our countries list are become object types. So it's also known as row type, row list, as I mentioned previously. It means we can add any kind of object and it will be converted into object type. In this case, we can use actually previously mentioned explicit casting. So I propose to modify the code in the following way, that before our variable, which our argument, list of countries, we explicitly cast this value, which is returned under index 2, into type of object type of string. And voila! Finally, compiler is satisfied and we can proceed with the code. Explicit casting is converting a higher data type into lower one, and since I mentioned object is a higher data type as it is a class of all classes. So let's print the data from our retrieved object into console. Oops. Why nothing is returned? Because we simply forgot about method system out print line country. Voila, we have received printed value into our console. It's United Kingdom. If we want to receive Lithuania, we change the index and we will receive Lithuania. So guys, at this moment, let's stop once again and switch to the slides. I will explain it a bit further. Okay, so what we have learned so far? We learned so far that using, if we write the code without generics, we need to use explicit casting. And this is the problem number one. The problem number two is lack of type safety. If we write the code without generics, then during compilation time, we cannot be sure that the object which we trying to insert into our collection, in our case it's a list, it is a correct object. So let's get back to integrated development environment and proceed with this example. So let's create an integer type of value. And let's add this value into our list of countries. So what we have here, on line number 13, we have created integer type of variable and assigned the value 11 to this variable. And on line number 14, we have added this variable number, which is holding value 11, into our list of countries. We know that the list of countries is holding only string variables. However, another developer who will work with your project in future and who might use this list in future as well might not know that it's holding only string variables, and assume that we need to add a number of countries or country code, for example, or just simply by mistake he will add another object, and that's not good. However, right now we see that we don't have any restrictions. We have some warnings from a compiler, but still, if we will run the program, program will work correctly and we will print out the value which we receive under index 0. So let's modify a bit this method, print countries. Okay, so what we did here, we have created a simple loop which prints list of countries as item, which is explicitly casted into string type of value. So let's run this program once more. And what we see, we have printed Lithuania, United States, United Kingdom, 3 countries, and then later on we received class cast exception. And it says that integer cannot be casted to Java language string type of variable. And this is correct. So when you might wonder why the program does not work as we want, I mean, exception says that integer which we added on line number 14 cannot be casted to string. But previously as well, we said that we can add any type of object into this list because it accepts any kind of object, and object is the father class of all classes. And yes, it's also correct. We can add any type of object into that list, and integer as well, integer type as well. Nevertheless, when our method print countries tries to cast this ith value, and when he gets to number and tries this value cast into string, we receive exception because Java cannot cast string value since it's in convertible types. Let's write the following code. You see, in convertible types, Java cannot cast integer into string. So you might wonder why the compiler allows us to add integer type on line number 14 into our list of countries. Well, this is because when on line 22 we use explicit casting and trying to cast variable into the string, this time not compiler but runtime trusts us and assumes that we compiler trusts us and assumes that we know what we are doing. So Java runtime already detects that we were trying to take integer value on line number 14 and cast this value into string type, which is inconvertible type, and thus runtime went ahead and he threw out this class cast exception. And this is exactly called as lack of type safety problem, which we use in generalized code without generics. So it means that we can add any type of object into our list, and compiler will allow us to do that. However, when we run the program, when we run the program, we might get into trouble. So let's stop at this moment and let's summarize what we have right now. At the end of the day, we have two issues. The first one is explicit casting, and the second one is lack of type safety. So let's summarize what we have learned so far. First of all, if we run the code, if we write the code without generics, explicit casting is required. And secondly, type safety without generics is not guaranteed. So let's rewrite the code with generics, and we will see how generics are solving these issues. Let's jump into integrated development environment. Let's create a class. This time, let's name it generics code class. Let's try the same code more or less, but this time with generics feature. So let's create the list. So what we have? On line number 8, we have created list type of object with parameterized type, which is string. String is inserted into pair of angel brackets. This indicates to compiler that this list is going to accept and hold only string type of objects. So we can say that on number 8, we invoked the generics feature. If you notice from the both sides, we have string type of parameter declared in angel brackets. If we would add another type on the right side, then code would not compile. Let's change the type on the right side to integer. Okay, so what we see right now, we see that it's again incompatible types. Compiler found Java utility array list java.lang integer type, and the required type is string. Let's delete this incorrect integer type from the right side. What do we see right now? Compiler does not show us any message and code seems to be fine. And yes, this is correct. You see from the right side of when we instantiated the object, we have just simply two angel brackets. And this two angel brackets, also known and called as diamond operator, which basically in very simple language says that it doesn't require to us declare once again the same type of parameter which is declared on the left side, which is in our case string. Next, let's go and add some values into our list. If you observe right now, this time our list is asking something of string type, not object type, as it was previously with non-generic code. So let's go and add some countries here. Let's also call the method. So what we did here, and yeah, we see that still we cannot resolve this method. We need to write this method. So let's write once again this method. Private, static, void, print countries. So what we did so far, on line number 8, we created a list with generics feature. On line number 9 and 10, we have added two countries which a type of string into our list. On line number 12, we have called the method print countries and passed the argument countries. On line number 14, we have created a method which is called print countries, which is private, static, and without return type, which means it's void type. And it accepts list type of object, but it's not following with angel brackets as we have here. And there are no argument string. If we don't specify angel brackets and don't pass any argument, it is still raw type. However, we see everything is fine and compiler right now is satisfied. Let's write code. Okay, so what we see right now, online we have incompatible types, found Java language object, require type, again string. Well, we have created variable of type of string and assigned value from our list also, which is type of string. But unfortunately, compiler again is not satisfied. So again, required type is string and provided still object, even though that previously we have observed, if you just remember, that it accepted only string types. So where is the problem? This time we did not use casting as we did previously, because we simply use generics, right? Not quite. The problem is that on line 14, the list type is still raw type. If we want to use generics then we need to invoke it even in parameter. So let's modify the code again and add into list angel brackets and this type of string. Angel brackets and type of string. Yoo-hoo! You see, the moment when we added angel brackets with string type, compilation was successful and compiler is satisfied. So let's do and print our country. So we see Lithuania, which is under index number 0, was printed into our console as it was intended. So the problem number 1, which we had when we used non-generics code, is gone, and it is explicit casting. We don't need any more explicitly cast this value into the string. Uh, our integrated development environment also says that it's redundant, since we have already declared that this list is going to hold only string types. And this argument, which we're expecting to receive here, is also going to have only string type. Second issue, if you remember, was with lack of type safety. So let's understand how it works. Let's do exactly the same thing as we did in non-generics code class and add integer into our list. So what we see right now, this time we're being already informed on compilation level that something is not okay. And our compiler shows as error. Required type is string, provided is integer. It did not happen with generalized code when we didn't use generics. But when we use generics, we're already being informed before runtime that types are incompatible. So on the line number 8, we declare that our list of countries will accept and hold only string type of objects. The moment we try to add another type of object, we receive compilation error. And this is how type safety is guaranteed with usage of generics. Since compiler does not allow us to add a wrong value into list, we will never compile the code and run in this program. It means this provides opportunity to find issue already not on runtime when the code is being used, but at the moment when we write the code. This is how this generics, so this is basically how generics solves two issues: explicit casting and lack of type safety. Let's summarize what we have learned during the first lesson in this generics module. So first of all, explicit casting is not required with generics. Explicit casting is required only in case if we use non-generic code and write the code without generics. Secondly, type safety is guaranteed with generics, and it is achieved with by a simple reason. We run into the problem during compilation time, but not during runtime. Thirdly, raw type of usage is not forbidden yet in Java, but it's strongly not recommended. The reason is very simple. The whole code which was written previously is written without generics. I mean, there was a time gap in Java when before Java introduced this feature, and the whole code was written without generics, and Java must support this legacy code. So due to this reason, right now Java allows us to use a raw type, meaning we can write the code without generics, but it is very strongly not recommended. The fourth reason, not the reason, but the fourth thing which we learned in this lecture, basically that it's always better to find error, bug, run into the problem during compilation time than during runtime. In that case, we have time to fix the issue in compilation time. But during runtime, unfortunately, we don't have such possibility. And the last but not least, two angel brackets from the right side of the declaration of collection is called diamond operator, and it's totally fine to use this diamond operator. We don't need explicitly indicate to Java once again what kind of collection it's going to be. So that's all I would say for this lesson number 1. Thank you. Thank you. If you have any questions, please raise them and write them in comments. The next lecture is going to be about the methods, how generics are declared, about classes, and mm, about definitions which are used actually in generics. So thank you a lot. Have a great day.